All right. 7.1 is parabolas, but we're starting a new chapter on conic sections. I think this is the coolest thing, but when you take this cone and you put another cone on top of it like this, has a special name I would have never known called the double napped right cone. But you can get all these different shapes by intersecting or slicing a plane through this shape. Okay, when you slice here parallel to the base, you get a circle. Make sense? Okay, just slice that thing off, you get a circle. If you slice at an acute angle to the base, though, you get an oval or an ellipse, okay? So when you're in kindergarten and your teacher says, what shape is this? And you said oval, it was really an ellipse. A parabola is when you slice parallel to one of these slant heights. Do you remember that word from geometry? Slant height? Okay. Now remember, a parabola keeps getting wider because that cone would get wider if it were to continue on. Then if you slice perpendicular to the base, you get two little things with asymptotes called hyperbolas. Okay? That's pretty cool. Those are the things we're going to study in this chapter. Now, there are also things you can slice and get. If you went right through that little spot where they intersected, you'd get a point. If you just barely touched the edge, you'd get a line. You could get intersecting lines. These are called degenerate conics, and we're not going to study those, but I thought it was so cool. All right. A locus of points from geometry. We used to do a lot of locus of points in geometry. They don't talk about it much anymore. If I told you all to put a dot on your paper, and then I said, now locate all the points exactly 1 inch away on your paper, what shape would you end up with? A circle. If I took away the words on your paper, and I said, there's a dot hanging in space right here, and I need all points 1 inch away in space, you'd get a sphere, right? Okay. If I said, here's my pencil, and I want all points 1 inch away, you'd get like a cylinder, right? Idea? Okay. That's called the locus of points. So here's the idea that we're going to use for parabola today. If we had a line, oh yeah, pretend I can draw, okay, and a point, and we want a locus of points of all the points the same distance away from that line as they are from the point. Now, we'd all figure out that I can put a point right there, and it's the same distance from here to here as it is here to here. Does that seem okay? Yeah. But there are other points that are the same distance away from this point, which is going to be called the focus point, as they are from this line, which is going to be called the directrix. In other words, if this red dot was, I don't know, a gas station, and this is a highway, okay? And I want to put my business where my workers can get to the gas station or to the highway the same distance away. I don't know, I'm making something up here. But if I pick a spot here, does that look roughly the same distance there as there? Okay, pretty close. When you measure to a line, you measure at a perpendicular, right? Okay. What if I pick, I'm eyeballing here, up here? Do you think that might be the same distance as that? Roughly? If we measured a straight line instead of a curvy Q line like Hoffbauer drew? Okay. What about here? Might that one be the same distance here as here? Okay. All the points that are equidistant that wasn't bad, give me a break, okay, would make a parabola. All the points on here are equidistant from this line as they are from this point. Now that point's not the vertex of the parabola. Does everybody see that? That's the focus, okay? This is called the focus point. Now let me tell you why they use a focus point. Anybody ever see a parabolic microphone thing at a football game or something? The guys on the sidelines holding those things up to catch all the sounds out on the field or at the tennis match or wherever. Those are parabolic. Guess where that microphone is? It's right at the focal point or the focus point of that parabola. Make sense? See a great big satellite dish out in somebody's yard, if they still have them anymore?
Yeah.
But the focal point is where the receiver sits, because all those waves are focused. Yes?
I was just going to ask if you have anything to do with like orbits.
Most orbits are elliptical.
Oh, yeah.
So yes, we will get to ellipses. Yes, absolutely. And the focal point of an ellipse is very important. Okay? Great question. But these are parabolas, same kind. Okay, this is what we're going to need to know today. Okay? When we go to write these equations, guys, let me get a different color here. This, oh, I thought I was getting, is that purple? Doesn't look purple to me. Okay, right there. That distance is equal to this distance, yes? This distance is called P. Okay? What is this Sorry. What's the name of that point right there? Yes, that's the vertex. Everybody good so far? Okay, so we've covered some concepts. Now before we do anything else, we need to talk about, we've done parabolas, yes? You kind of thought you'd killed parabolas, right? We even learned this form. And we learned the vertex finder recipe and all kinds of crazy business like that. Okay? Well, we're going to learn yet another form of a parabola. Okay? The form we're going to learn today Okay, does that look like it could be this one rearranged? The y minus k, get where that came from? And then they divided the a over here and it turned into a 4p. So 1 over a is actually equal to 4p. When you learned it in Algebra 2, at least if you took, I think if you took both honors and regular, you learned it like this. 1 over 4p is equal to a. And then you did a bunch of stuff to find the focus and the directrix. I don't know if you remember, but you did. We're going to rearrange the format a little bit in this class. Okay? The part of the reason is we're now going to have parabolas that open sideways. What do you think is going to have to change when the parabola opens sideways? Think about that for a minute. When it said y equals x squared, that meant if y was 4, this could have been a plus or minus 2, yes? Either one squared. So I went left 2 and up 4, right 2 and up 4, and I got this shape. Anybody know what's going to change to make it open sideways? Okay, we could do a square root, but this does open sideways, so what happens when we square that? The squared is going to be on the y. Okay, absolutely. The squared is going to be on the y because now when x is 4, y could be plus or minus 2. So if x is 4 over here at 4, I could go up 2 or down 2 and I get a parabola. Does that make sense? Square in the other one. All right. Here we go. Let's go back and look at this, see if we talked about all this. So the directrix is that special line, remember the highway? The special line that the parabola opens away from. The focus is that point inside the curve of the parabola, always inside, and those are equal distant away. So directrix is going to be equation of a line, focus is going to be a point. Axis of symmetry we did, yes? Remember doing axis symmetry? It's the one that goes right through the middle. Okay. These are the two equations, but they're on this chart I'm going to give you in a second. This little note over here, it says when you get to calculus, instead of saying concave, you're going to say concave up instead of opens up. Concave left, or the concavity is to the left instead of opens, okay? We're just going to stick with the words we're used to, though. All right, on this is actually off your sheet. This is really important. P is the distance from the vertex to the focus or from the vertex to the directrix. Did you get that when I did that on that picture? Remember my purple line was P? Right here? P is that distance. Everybody good? All right. Now we're going to go to this slide. You get to use this. You will be given later in this chapter this picture on a reference sheet, okay? Because while I think it's important that you've been introduced to all these conics, there's crazy rules for all of them, and it's not something you have to memorize for the rest of your life, okay? The focus, the directrix are these equations down here, okay? This should make sense to you. If P is positive, it opens up, negative, left, yes? And down, thank you. Negative, down. That's when the x is squared, up or down, yes? We're used to that, right? X squared was the ones that opened up and down. Y squared means they're going to open sideways. If it's positive, guess which way? To the right, negative to the left. Okay. You can use this. I am not going to refer to this that much today because I would like you to learn to do this conceptually, but if you need to refer to this to figure out these, you can. And I'll try to tie back to that a little bit. Here's my really fast example. You don't have to write anything down. Okay. If I write this down, y plus 5 squared equals negative 12, x minus 2. Underneath it, I'm going to write what I know, y minus k squared equals 4p x minus h. Okay, guys, listen closely because you're going to get confused in a minute. The x always goes with the h. Got it? The y always goes with the k. So when you pull out the h and the k for the vertex, this one is going to have a vertex of 2, negative 5. Everybody all right? Opposite of this, opposite of this. All right, what is P? Look right here. P is negative 3. Which way does this open because the y is squared? It opens left or right because the y is the squared one. And the negative means it opens left. So this is what I do. I go 2 to the right, down 5. I put the vertex. I say 3 units inside of here is the focus because it's opening left. 3 units back this way is where the directrix is going to sit. And the line that connects the focus and the vertex is the axis of symmetry. Okay? All right, rather than watch me do one, let's do one together. I'm going to skip this one. If you need more practice, go back and look through this example, okay? Because they do it with the whole algebra stuff off the chart. I'm not going to present it that way. I'm just going to present it as a concept. All right, I'm going to write underneath here to help you, though. Y minus k squared equals 4p times x minus h. So what do you know? H is 3, k is negative 1, the vertex is at 3, negative 1. Gosh, you guys got a lot out of that in no time. What else? P equals 2, because 4p is 8 right here. All right, is the y squared or the x the squared? The y is squared, so it opens left or right, and it's positive, so it opens right, okay? All right, so I'm going to go plot the vertex at 3, down 1. There's the vertex. It opens to the right. I'm going to put a couple little dots over here to remind myself that, but I want us to find at least one ordered pair and plot it halfway accurately. We'll do that at the end. Right now, how do I know where to find anything else? Go to the vertex and go inside or further to the right 2, and I'd find the focus. What would that be? Okay, we added 2 to the x, right? We added the p onto the x. We go to the left 2, and we get a dot here, but the directrix isn't a dot. It's what? A line. So we have this directrix whose equation is, be careful, vertical line is always x equals, and this one is 2 units to the left of 3 would be x equals 1. Okay? Axis of symmetry. Guys, I always just remember it this way. Look, I look at the focus and vertex. The photex, that's those two things combined. Okay? What do they have in common? They both have what? Y equals -1. That's this line that connects them. That's the axis of symmetry. Okay? This was the axis of symmetry. This was the directrix. All right, did we do everything? It says identify the vertex, the focus, the axis of symmetry, the directrix, and now graph. All right, this is actually the hardest part for most students, is I want you to find one more point, and it doesn't have to be 100% accurate, but that will give us an idea what this looks like. Now, if its vertex is 3 to the right of the y-axis, and it's opening further to the right, we want to pick numbers out past 3 to put in for x, or we're going to get imaginary answers. So, I don't know, what do you want to pick? 6? I heard a 6, I don't really care. I heard a 5, yes, at the back. But yeah, that's the problem. Not. All right, put in an x equals 6. 6 minus 3 is 3 times 8 is 24, right? This is actually a nice, that it doesn't come out nice. I did some earlier today, and they came out nice, and I was like, well, how did you pick a number that came out nice? Doesn't matter. I don't care. The square root of 24 is roughly what? Square root of 25 is 5. You can type it and get, yeah, 4.9. I'm just going to go roughly 5. So when I square root, I get y plus 1 equals roughly 5. If I subtract 1, I have y is roughly 4. Okay, so when I put in a 6, I got out a 4. That's not 100% accurate, but I don't care. 1, 2, 3, 4, 5, 6. It's out at about, oh, yeah, 6, 4. 1, 2, 3, 4. Okay, how can I find another spot? It's on the same, but it's on the other side of what?
The Y.
It's on the other side of the axis of symmetry. This distance is equal to this distance, okay? It's on the other side of the axis of symmetry, which actually puts it, because this graph paper is not symmetric, puts it on the bottom here. So the actual parabola goes through the vertex and through those points. The greater the p-value, the wider the parabola. Do you remember when we did it with an a value? An a value, the bigger it was, actually made it narrower. But this is a reciprocal value, a reciprocal relationship. Remember, it was 1 over 4p. All right, moving on. Anybody want to try this one? Not yet? Okay, what can you tell me? X minus what? What always goes with the x? H equals 4p y minus k. So who's got some info for me? Jacob, tell me something. What? Yep. Vertex is at -2, 1. Everybody okay? The opposites, okay? Other Jacob, what's the p-value? P is 1, okay? Trey, which way is it open? Okay, the x is squared. X is squared, so it opens up or down. P is positive, so it opens up. This graph paper is counting by 2s, so be careful. -2, 1 is over here. I don't like this graph paper because P is only 1 unit away, so it's all scrunched together here. It's opening up. So the focus is 1 unit up from there. What would that focus point be right there? -2, 2, 1 unit up. The directrix is an equation 1 unit below the vertex, which would actually be the x-axis, which is the equation y equals 0, okay? You're confused? Go to this chart. We are doing one that opens up and down, right? So it says the focus is at h, k plus p. As long as you know h and k and p, you just plug stuff in according to this. Everybody okay? I'm just not referring to this chart because I kind of like the idea that you understand the concept. Okay. We need a point. What do you want to pick to put in? Oh, we forgot the axis of symmetry. They have in common an x value of -2, so it's a vertical line through -2. All right. What do you want to put in? Okay, if I put in an 8, I'm trying to figure out what y value I get out. 8 plus 2 squared equals 4, y minus 1. By the way, you could pick to put in a y value. Just make sure when you plot it correctly. 8 plus 2 is 10. Squared is 100. Divided by 4 is... Did we do that right? Did I do that right? Equals y minus 1. I just divided first, so I didn't distribute. So I got 26. I don't think that's going to fit.
Maybe it is in the graph.
8, 26. So the good news is we know it goes up pretty quick, right? We might have to pick another value. Try 4. If I put in a 4, I get 4 plus 2 squared equals 4 times y minus 1. 4 plus 2 is 6. 6 squared is 36. Divided by 4 is... So y minus 1 equals 9, which makes it 4. It's up at 10. That's 1, 2, 3 boxes away from the line of symmetry, so it's also at -8. Make sure you go through the vertex, not the focus when you draw it. Mine isn't very good. Should be a little flatter. It's a little too V-like. But anyway, you get the idea. Everybody okay? I want you to find when it asks you to graph on your homework. You have to write all those things, and it's in the directions, okay? Write the vertex, focus, axis of symmetry, directrix. But I also want you to find one point so you get a nice, accurate graph. You don't have to find 10 ordered pairs. What do you notice about these? Can you type this in your calculator?
Yes.
Can you type this in your calculator?
No, it's not a function.
This particular one has a y squared, so it opens sideways. So it is not a function. Beautiful answer. You could type it in your calculator, but you'd have to square root, add 3, and you'd have to remember to put a plus or minus somewhere. Otherwise, you'd only get half the parabola. To get both halves, you'd have to put something in y1 and something in y2. So no, these aren't something you're just going to rely on your calculator for. All right. What can you tell me about this one? Vertex is at 6, 3. This is 4p, so if 4p is equal to 2, p is only 1/2, so the vertex and the focus and directrix are all really close together. What does that mean is going to happen? It's going to be hard to graph, but to make it narrow or wide, do you remember? It's going to be narrower, yes. It's the opposite of what A did. Yeah, I know, it's confusing. All right, I don't know, let's plot that and go from there. 6, 3. Oh, which way is it even opening? Because I'm going to go the wrong way otherwise.
Opening
Sideways, right? And it's positive, so it opens right. Guys, I'm recording, so it would be, I write recording, not right. So it'd be really nice if you were answering the questions, but not chatting about random things.
Wow.
Okay, half a unit inside of here would be what? And I'm not going to draw it very accurately. Half a unit to the right of 6 would be 6.53 would be our focus. Look at the chart. Does the chart tell you that the focus is at, I'm guessing it says H plus P? Is that what it says for focus? H plus P? For one that opens to the right? Okay? So you could have plugged the values back in and done it that way. The directrix is going to be to the left a half. So it's going to be at x equals h minus p, which is what? X equals 5.5. Very good, Jenny. All right. Axis of symmetry, connecting these, y equals 3. And you should label those. I always forget. Directrix and axis of symmetry. Okay, do I have everything I need? Except a point. If it's opening off to the right, what kind of a value do I have to pick to put in for x? Something bigger than the vertex over here somewhere. What do you want to try? 10? Okay, if I put in a 10, it'll say y minus 3 squared equals 2 times 10 minus 6, because I'm putting it in for the x. 10 minus 6 is 4. 4 times 2 is 8. Not something that's going to square root perfectly. But we're going to get good at estimating. 9, the square root of 9 is 3, so this is a little less than 3. Add 3 and we get close to 6. Good enough for me. What did we put in? I forgot. 10? 10, 6. It's not an accurate point, but it's close enough. Over to 10 and up to 6. That is kind of looking narrow, isn't it? Narrower. That's bad drawing. Okay, here was our axis of symmetry. So it's pretty close to 0, I think, would be the other. Everybody okay? And if it's a test or quiz and you were worried about getting a better, plug it in and get a decimal. I don't care, but on graph paper that counts by 2s, you're not going to get very close anyway, right? All right, this one looks miserable. Anybody see what the problem is? No, P is not 1/48. Does anybody see why? I thought it was going to be 2, and then I realized something's going on. The 4P is supposed to be on the non-squared side, right? So we got to multiply this by -12 to get rid of it, and that's going to go over here. So will that look much nicer? Okay, I want you to work on that. Joseph, put that away. Evan, do you have the vertex down yet? Sounds good. Crystal, did you find the p-value yet? Very good. John, did you decide which way that would mean it's going to open? Yes, it's an x squared, so it's opening up or down, and it's negative, so it's going to open down. So now I'm moving over here. Trey, you can tell me where the axis of symmetry is? How about you stop talking? All right, I'm going to graph it next anyway. 3, 6 is up here. If it opens down, where's the axis of symmetry? At what equals 3? Yes. Axis of symmetry is at the line x equals 3. Good job, Ben. Okay, how far do we go before we find the focus or the directrix? Right here it says 3 units, right? So 3 units inside of here and 3 units back up this way. Remember, we're counting by 2's. So what is the equation of the directrix? Anybody come up with that one? It is y equals, but I don't think it's 6, is it? The vertex was up at 6, so 3 more would be 9. The focus is 3 units below 3, 6, which would be 3, 3. Okay, if you're struggling with this, what does it say on the chart for a parabola that opens up and down? It says focus is at h, comma, k plus p. And what does it say for directrix? Y equals k minus p. So if you have the h and the k and the p, all you gotta do is plug those in, right? Okay. What do you want to try for a point? X equals 6? That's so close, guys. The further out you go, the better. X equals 0 is here, so that's going to cross. I'm just saying.
0.
All right, let's do 0. Make them happy. Okay, that gives me 9 equals negative 12 times y minus 6. That gives me negative 0.75 equals y minus 6. I'm dividing rather than distributing. What's 5.25? If I add 6 over there. So if I go over 0, I go up 2, 4, 5, and a little more. But see, that's so close it doesn't really, that's all right. My graph was pretty close. Good enough. Okay? How you feeling? Can handle these? Especially if you get to use a reference sheet with the chart? Okay. Got good news for you. I actually think this next part is easier. I like these. Okay. It says come up with the equation given a set of information. These are kind of like a puzzle. Okay? This puzzle says we have a focus at 4, negative 3 and a vertex at 1, negative 3. Again, you could go to the chart and try to figure out what that means. To me, the vertex tells me h is what? 1 and k is negative 3. Now, I need to figure out p and I'm done. I write the equation. Oh yeah, positive 3 and negative 1. Thank you. Yep. Well, no, you don't. When you put it into the equation, you do. Sorry. Yeah. What you need to do to find p, though, is find the distance from here to here. How far apart are those 2 points, guys? Be careful. If we're at 1, negative 3 for the vertex and negative 4, negative 3, that's 4 units to here and another 1, right? So 5 units. So p is 5, almost. It's opening left, so that tells me negative. Okay. What does this start with? If it opens left, which one is squared? The y. So we have y minus not 1, plus 3. Y minus negative 3 or y plus 3 equals, nope, not negative 5. Yeah, it's 4p, which would be negative 20. X minus k, which is 1. X minus H, thank you. X minus H, which is 1. All right, let's try this again. Gentlemen, stop. Negative 1, 5 is a focus point, not the vertex. The vertex is at 2, 5. Which way does this open? If this is the vertex and this is the focus. It does open left. These are the ones I really don't care if you just do a really rough sketch, okay? I'm not going to make you label everything. It does say and graph, and it says on the homework with the given characteristics, but I just a rough sketch, come up with the equation, okay? Otherwise, this assignment will take 2 days. What do you know about H and K? Yep, the vertex is just HK, so H is 2, K is 5. P is how far apart these are. How far apart are those two? Okay, except it's opening left, so we need negative 3. Anybody write the equation? What do you have? Okay, what do you think? X minus H, that seems right. Y minus K, that seems right. The negative means it's opening left. Okay, I didn't worry about drawing mine accurately. The 12 actually means it should be what? Pretty wide, right? Pretty wide, flat. Yep. All right, this gives us different information. This one says the directrix is up at y equals 6. Make sure you know that's horizontal line. And it says the vertex is at 5, 3. Did they need to tell me it opens down? No, because couldn't I, if I knew where the vertex and the directrix, it always opens away from the directrix, right? And goes through the vertex. So it had to open down. Okay. What else do you want to tell me? We actually know H and K, right? Do we know P? P is this distance, right? I don't think that's 1.
Oh, I was thinking 5.
Yeah. It's the up and down change from 5, 3 up to the line y equals 6. So P is 3. And it's going down, so it's going to be negative 3. How would you know that if you didn't get that whole concept? What does it say up at the top for a parabola that opens down, guys? What does it say for the directrix? Tell me. Y equals K minus P. If I knew the directrix was at 6 and I knew K was 3, could I find P? I get negative 3, right? After some algebra. Okay, so you can use the information from the chart as well. So write the equation, anybody?
X minus 3 squared equals...
What's the x of the vertex? The x,
Oh, I'm sorry, 5.
but you're right, it is an x squared, right?
Yes. Equals negative 12.
Yep. Everybody okay? One more? Okay, last one. Try this one on your own. Ooh, they give us a focus and a directrix. How are we going to figure out where the vertex is?
What's the label on the axis?
Just whatever you want to make it 1. Oh, I think my directrix is now looking too healthy. Directrix is going this way. Focus is here. How do you find the vertex? It's in the middle, right? If this was the focus, the vertex would be exactly in the middle. Okay. Unfortunately, this is really tiny. Okay, 1.5 and up 1. And over here at 1/2 is the directrix. What's halfway between 1/2 and 1.5?
1.
So the focus, or the vertex, is actually where? 1, 1. What is the P, or the distance? P is 1/2 or 0.5. Opening to the... Oh my goodness, that was bad. So the equation?
Y minus 1 squared equals 4.
4 times 1/2, which would be 2. Okay, did we get the right variable squared for one that's opening to the right? Okay. All right, the book assignment, the first ones are graphing, and you need to be very careful. Make sure you list all the things it asks for and that you graph them nicely. The second half is writing equations. You should sketch a graph because it will help, but you don't have to label the axis and every little thing it asks for on the second half, okay? It doesn't have to be perfectly nice. Come up with the equation. All right. Does any